Hey guys, this is the 1.2 notes for Algebra 2. This section is transformation of functions. All right, so this first page is just a page for parent functions. So this is something you want to keep for a while because you're going to be using these parent functions throughout like the units, not just unit 1. It's going to be like through the whole year. Okay, so just a parent function, what it is, right, is it's the simplest function in a family of functions. So what does that mean? Well, these are the basic functions. So as you can see, like linear right here, right? Normally, whatever number's in front of the x, right, is our m. So that's our slope. And then there should be a plus b, right, which would be your y-intercept, okay? But when you have just a slope of 1 over 1, right, the m is just 1, so it's just x there. And then if you have a y-intercept of 0, right, there's no b. So this is what f of x equals x looks like, right? And that's our simplest function, right? If we had like 2x plus 6, right, our slope would be 2 over 1. And we have a y-intercept of 6, and that would be part of the family of functions. Okay, so these are all the simplest forms, right? The reason I want you to memorize these, so I want you to memorize. Is because we're going to be doing transformations to these. So we're going to be adding things to this x, or this absolute value of x might add a 5. And what does that do to it? Well, if we remember how just absolute value of x looks, and then we know what this plus 5 means, we can easily draw our new function. Okay. So we have a constant, right? That means like f of x equals like 4 in this case. That's why it's just a straight horizontal line. We have a linear where we have a slope, right? And it's a line. We have an absolute value, right? Which gives a V shape. Okay. The next one's a quadratic, right? We're unit 2 focuses on quadratic, so it's gonna be like sort of a U shape. Cubic goes up, then almost flattens, and then goes up again, right? Or if it's negative, it does the opposite, it goes down, flattens, then goes down again. Square root function, right? Square roots, we can only have positive numbers, right? So it looks like that. And then right, we can only take the square root of a positive number. Exponentials look like this, logs and reciprocals. We're mostly going to focus up to maybe square root, the last 3, if we get to them later on. But right now, we'll probably get to reciprocal, but right now, we're going to focus on probably up to cubics. Okay. So this is a page you want to keep a hold of or reference back to. And this is something you want to try and memorize, like maybe up to cubic. So cubic, quadratic, absolute value, linear, and maybe the square root for now. But yep, so now we're actually going to go into the notes, which is transformation of functions. Okay, so the first thing is a warm-up. It says the graph of the function is absolute value of x, right? We know it's a V shape, right? You can see it's got a slope of 1 over 1, right? Going to the right, and then also a slope of negative 1 over 1, right? Now it says graph the function x plus c several times with different values for c. Okay, so whenever we plug in something for c, what it's going to do is it's either going to shift us left or right. Oops. So if we made an absolute value of x plus 1, now this is something you need to remember. When it's x, right, plus c, we go the opposite direction. So normally if you saw +1, you'd think go right. Well, we go the opposite direction, right? So this would be left 1, okay? So whenever you see a plus a number, you're going left. If you see minus, you go right. Okay, so x plus, you go left, x minus, there we go right. Okay, so it's the opposite when it's inside that piece. Okay, so if we did x plus 1, right, x plus 1, right, we're shifting our whole graph, everything to the left one, right? So this point moves to here, right? And then we still have a slope of 1/1. So it looks like this. Okay, so this is the x plus 1 graph. This is predict what will happen if the graph C is greater than 100. So if it's greater than 100, right, it's going to go way to the left. For C is greater than 100. Right, and then what if C is between 0? C is in between 0 and 1/2. Well, it's going to do a small shift to our left, right, because it's still positive, right? All right, but it's going to be something, it could be here, 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 anywhere in between that 0 and -1, right? It's your point where it changes, meaning the vertex of it. All right, so let's look at an example. Right, again, we're translating the function. So translate means we shift either left, right, up, or down. Okay, so we're shifting our parent function. Okay, so it says graph the function x squared for the domain -2 to 2. Right, so we're only looking from -2 to 2. Right, our graph goes 0, 0, 1, 1, -1, 1, 1, -1, 1, sorry, and then 2, 4, and -2, 4. Because when you square root 2 and -2, you still get 4. Okay, so there's our x squared function. Okay, so this is x squared, and that's in between -2 and 2. Now, right, it says graph of G is obtained from the graph of F. We're going 3 units down. Right? How are the equations, domain, and range of F and G related? Okay, so we're shifting every point we see down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, here's our graph of G of X. Okay. All right, so, all right, if we look at it, so G of X, when we shift down, we're going to have x squared, and then we're going down 3. Okay, so -3. Only the horizontal shifts do the opposite, right? So f of x was x squared. If we're going down 3 for g of x, right, it's x squared -3. Okay, so now if we look at the domain, right, as we can see, it's still in between -2 and 2. So the domain stays the same, but our range is going to change because our range, right, our y values went down. So it's starting at -3 and going up to 1, whereas the first x squared started at 0 and went up to 4. Okay, so range, all right, f of x was from 0 to 4 for y values, and g of x was from -3 to 1. Right, those are the only -3 to 1. Right, that's your range. Right, so this is going to be a vertical translation because we're going down, right? And when we have a vertical translation, our g of x comes from original f of x or our parent function x squared, and then we either add or subtract something we call k. Okay, so this is a vertical translation, is when we have our parent function and then we add or subtract a number at the end of it. Okay, so that gives us our vertical translation. Now, part B is going to do a horizontal translation. This says graph the function x squared from the domain -2 to 2. So same as last time, right? We're drawing the same original picture for f of x. Right, f of x equals x squared. Now it says we want to go 3 units to the right. Okay, so we're moving every point 3 units to the right. All right, so it says, how are the equations? So now, remember I told you, if we shift left or right, we write the opposite. So x squared, now g of x, it needs to be inside the parentheses. So, sorry, my cat's yelling at me. It's x squared, oh, sorry, x, and then we're subtracting 3 because we went to the right 3, so it's -3. And then it's squared. See how it's in the parentheses? That tells us it's going to be a horizontal translation. All right, now let's look at the domain and range. So domain is the x value. So before it was -2 to 2. Now we've changed from 1 to 5 because we shifted to the right 3. So our domain for g of x is equal to 1, 5, right? And if we, and then this is our domain for f of x. Our range, we did not move up or down, so it stays the same. And now if we have a horizontal translation, right? Our g of x is going to be equal to f of x minus h. Okay, so remember your h, right? It tells you we're going the opposite. That's why it's minus. So technically our h here, right? 3 units to the right, that means h equals 3. So that's why we get x minus 3, because it's x minus h. Okay, so horizontal translation looks like this. All right, so the next thing we're going to go through is when we do, oh, sorry, my cat decided to walk on the computer, so drew that. We're going to do reflections across the x and y axis. So we're going to look at these two problems. So when we go across the x-axis, remember when you reflect over the x, we take the opposite of our y. Okay. Now, when we have functions, this means we're taking the opposite of the whole f of x function. So everything that f of x is equal to, we're going to take the opposite of. Okay, so we call it g of x equals opposite or negative f of x. Okay, so if we look at this problem, f of x equals 2x minus 6. We know we can find g of x by taking the opposite of that f of x, right? And we said f of x is 2x minus 6. So we're going to take the opposite of that whole 2x minus 6. So our g of x is 2x plus 6. So g of x equals 2x plus 6. All right. And then once we find the other one, we'll graph all three. We'll graph f of x, g of x, and then we're going to find h of x for a reflection over the y-axis. So again, a reflection over the y tells us opposite of x. Now in a function, that means we make our x negative in f of x. Okay, take opposite of x, or make it negative, right, in our f of x function. Okay, so h of x, right, our new function, is just equal to f of negative x. So anytime we see an x in our function f of x, we're going to take the opposite of it. Okay, so right, h of x is equal to negative, f of negative x. So h of x is equal to 2. And then instead of x there, we have negative x minus 6. So negative 2x minus 6 is what our h of x is. Okay, so important. When you reflect over the x-axis, you take the opposite of the whole function. When you reflect over the y-axis, we take only opposite of x in that function. Okay, so I'm going to make my g of x red and my h of x blue. And then I'll draw our original f of x here. Okay, so f of x is negative 6 for our y-intercept, and then a slope of 2 over 1. All right, so f of x looks like this. G of x is plus 6 for our y-intercept, and then a slope of negative 2, so down 2 to the right 1. I know I didn't draw it perfect, but here's g of x. And then h of x, right, has a negative 6. Oh, sorry, it's blue. Negative 6. And then we have a negative slope, right? So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. All right, so our h of x looks something like that. All right, now we're going to move on to stretches and compressions. Okay. So the first thing we're going to look at is a stretch. Okay, so you'll see we have an f of x equals absolute value of x. So absolute value of x, right, it looks like this. And it's from negative 4 to 4. So right, this is our f of x equals absolute value of x. Now, what happens if we multiply that function by 2? Well, what it does is it's going to stretch this vertically. Okay, so what it's going to do is actually make it thinner when we multiply the whole function by a number. Okay, so what we're going to do is we're going to make a chart. Okay. The first thing is going to be our x, what we get for f of x, and our g of x, which is 2 times f of x. Okay, so, all right, say we start at -4, because our domain starts at -4. Our f of x is going to be 4, right? Our y value, right? And then if we multiply it by 2, right? 2 times 4, we get 8 for g of x. So -4, we're going to get 8. Now -2, right? We know is 2 for f of x. Now for g of x, right? It's going to be 2 times 2, so 4. Right, so -2, 4. I should be marking this in a different color. Sorry, here we go. Then you'll kind of see the pattern, right? 0, 0, so 2 times 0 equals 0. So 0, 0. And then if you can think about it, right, 2 should be 2. And then 2 times 2 is 4. Right, so we get 2, 4. And then we should be able to match it up for the next one. It should be 4, 4. So 2 times 4 is 8. So, right, here's our g of x. It's equal to 2 times f of x. Right, so this is called a stretch, right, a vertical stretch. What a vertical stretch is, it increases the distance between points with the same factor. Okay. And now our domain, right? The domain is still from -4 to 4, so it stayed the same. Our range changed though, right? Instead of from 0 to 4, it now goes from 0 to 8. Right, for g of x. And our f of x was 0 to 4. All right, so essentially double our range, right? Because we multiply by 2. All right, now we'll look at a compression. Okay. Now a compression, right? You'll see h of x is equal to f of 2x. Okay, so you see the 2 is inside the function. Okay, so what we're doing is we're multiplying that x inside the function by 2, right? Sort of like when we did the reflections, right? When it was f of -x, we made all the x's negative. Instead, we're making all the x's 2 times whatever that x is. Okay, so again, we're going to make another table. All right, so our first one is x, where f of x is, and then h of x is equal to f of 2x. Right, so x is, say, so let's draw our function again. So here's our f of x. Now, right, when we solve for this, right, say our x is -2, right, our f of x is at 2. So our h of x is the absolute value of 2, right, and then our x is -2. So the absolute value of -4 is 4. Right, because remember f of x is x, so technically, right, we're doing absolute value of 2x. Right, that's what we're solving for. And when x is -2, that's where we're plugging in here. Let's try 0. Right, so that was at -2, 4. Right, and then we have 0. F of x is 0, so 2 times 0 is equal to 0. And then let's try 2. F of x is at 2, so it's 2 times 2. Absolute value of 4 is 4, so 2, 4. And, right, there we go. But again, we're going with this, as you can see, right, our range stays the same, but our domain only goes from -2 to 2. So domain of h of x equals -2 to 2, where we knew the f of x domain is -4, 4. Right, and this is going to be a compression, right, because we're compressing our function, right? And this decreases distance between points with the same factor. So this decreases distance. And if we go back, if you go back to the stretch, right, stretch increases. All right, now what we're going to do is use those informations about stretches, compressions, reflections, and translations. And we're going to use them to first find the equation after a certain transformation, or we're going to have to identify next the transformation of the parent function given that transformation's equation. Okay. So this one says the graph of y equals absolute value of x plus 4 minus 5 is reflected across the y-axis. What is the equation of the reflected graph? Okay, so we're doing a reflection across the y-axis. So if we remember, right, a reflection of across the y-axis, right? So our f of x, right? Oh, sorry, g of x, right? So say our original f of, this is our f of x up here, right? So our g of x is equal to, when we take a reflection across our y-axis, remember, we're taking f of negative x, so the opposite of all the x's in our f of x. Okay, so if we know our f of x, right, is x plus 4 minus 5, right, and x plus 4 is an absolute value, right, what we're going to do is we're going to take the absolute value of negative x plus 4, and then we subtract 5, and that is our g of x. That's it. Okay. Remember, if we did a reflection across the x-axis, we'd be taking opposite of this whole thing, right? But in this case, we're only doing a reflection across the y, so we only need to take the opposite of the x value. All right. All right, we'll go to the next problem. All right, now this problem says identify the transformation. Okay, so you're given this g of x, and our parent function is f of x equals x squared. Okay, so we're going to need to identify the things that happen to it. Okay, so we have a 2 outside, right? We have a minus 3 inside, and then we have a plus 5 outside at the end. Okay, easiest one to identify is a plus or minus at the end. That tells us our vertical translation, whether we're going up or down. Okay, so if it's positive, that means we're going up, right? And then how many? 5. Okay, so up 5 is a vertical translation, and right our k is equal to 5. Remember, our k represents our vertical translation. Now, this one, when it's inside our parentheses or absolute value, right, we should know that it's going the opposite way. So if it's minus 3, that means we go right 3. Okay. The reason is because we know our h is positive 3 because it's x minus h. Okay. So remember, inside it's x minus h. So if it's x minus 3, we know our h is actually positive 3. And if our h is positive 3, right, we have a horizontal translation of h equals 3 or right 3. Then the last piece is this 2 in front. Okay, so if we have a number in front, we know we're either going to do a stretch or compression. Okay, so now we should know, if we look back to example 3, part A, we had we graphed the function g of x equals 2 times f of x. So that's exactly what's happening here. Right? We have another 2 outside of our function that's being multiplied to it. So what we're going to get, remember, is a stretch. Okay, and it's going to be a vertical stretch of 2. Right, and this number, right after this, I'm going to give you the general formula for transformations. We're going to call that number a. Okay, so a is equal to 2. Okay. Now a can represent a vertical, a stretch or a compression, and if it's positive or negative, right? So if it's negative, it actually represents a reflection as well. Okay, but I'm going to go over the general formula after this. All right, so if you printed out the paper, there's a little space on the bottom of that second page. And this is where I want you to write this general formula for it. So in general, this is what our formula is going to be looking like. So our g of x is our transformation of our parent function. And then we have an a times f of, and then in the parentheses is x minus h. And then on the outside, we have our plus k. Okay, so a right here, we said can be a reflection if it's negative. So there can be two things. If negative a, right? And it also represents a compression or a stretch. Okay. Next part is our h, right? We said our h represents our horizontal shift. Right? And it either goes left or right. Okay. Remember, because it's minus h, you're doing the opposite direction that you see. Okay. And then the last one is k. That's our vertical shift, meaning we're moving our graph up or down. All right, and that's it for the notes.